Hello, and welcome to this tutorial for AdonisFX version 2. My name is Lucas Ferry, and I'm a software developer at Imbibo. With a team totaling 40 years of cumulative experience in digital creatures, we have created AdonisFX, a digital anatomy framework used by the best visual effects and video game studios. In this tutorial, we will learn the basics of our new major release. We will start from a simple skin cluster, and then we will show what the results are on the actual simulated skin. So as you can see here, we have a skin cluster with no rotation. And this is generally the result that we would get out of a simple skin cluster. And we want to come to the result that you will see right here. So let me come down here and check out the rendered skin. So this is essentially the result that we want. So in this tutorial series, we will go through the different layers to achieve this result, mainly also being focused on the torsion that we have on the forearm area, and also the dynamics and the contractions that we have in the different muscles. So in there, we would be covering the muscle layer. So that is just a combination here for visualization. Then we will also cover the deep fascia setup, which you can see right here, being simulated. Then the external fascia, which is essentially surrounding all of these muscles. Then the fat geometry, so the fat simulation that we have right here. And then finally, we also have the skin, so the simulated skin. And then to be able to merge it back into the results of the animation, which is the skin cluster that I showed you at the very beginning, we have also the skin merge set up to just combine it together with the actual animation. Great. So let's jump right into it. So from the start scene that we will be providing you, you will find the following network. And let me just quickly show you exactly the different components. So we're bringing in the FBX, and we are actually computing an up and normal vector that we are going to use to orient these rivets with the KineFX rig. The reason for that is that we need the transformation matrices to be on the OBGL level. And given that the transform components on the KineFX rig are presented inside of the actual point attributes, we are mapping it to a different network. So here we have the N and up computation logic. And then with some scripting, we have prepared here this riveting system, which maps one rivet per joint. You can also import directly the FBX, but it's easier to pose the character using KineFX inside of Houdini. So you can see here that this will be presented like this. Let me go back into this network right here. Then we also have a rig pose node to be able to pose the different poses for rigging. And you can see also the joints have the setup for the pronation and supination, which we will then essentially use to create those sensors for firing the muscles. Then we have here 3 bone deforms, one for the animated skin, right here. Then we would have one for the mummy geometry, which is also animated. And we usually present this as one continuous geometry instead of separated bones. So the sliding avoids popping when jumping from one muscle to the other. And then we also have the shoulder geometry for the mummy. Then we also have prepared some naming conventions that we have to use. So for example, we are adding here the shape suffix to the path attribute, because essentially the path attribute is the one that we are going to use to actually set up the glue and to separate all of these entities right here. So essentially, if we had selected this node right here and come to the separate geometries option, it actually separates all of these geometries into the different pieces if it has the path attribute on it. So we can actually check that out quickly. And you can see that here the path attribute is just the name, and that's what's going to be used for separating all of those muscles. Great. So Here we have the static muscle geometry, which we're going to use for the rigging process. Then we have the external fascia, we have the fat, and we have the skin. And finally, we have the rendered skin, which is where we want to merge in the results from the actual simulation and the animation. And very important, we adhere to this naming convention here with ADN in and ADN out to make our setups compliant with our API, so we can actually transfer it back to Maya. So generally, it's always the ADN in prefix and ADN out prefix, and then the nodes that will affect that specific geometry in between. And then we have here the name of the geometry that has to match, for example, the name inside of Maya. And it's generally matching the name that we also give to the path, which is something that we might extend in the future to be a different attribute, but for the time being, it has to be the path attribute to be compliant with our system. And then to ease the setup process, we have also created some visualizers. It's just simply an object merge pointing to the shape of the mummy, for example. It can also be the mummy plus the shoulder area. That's something that we may tweak later in the tutorial. And then we also have the joints visualizer. And at any moment, we can just hide this. But the idea is that when we do show all objects or goes to other objects, we actually see the targets, so we can rig this properly. So now that we have introduced the scene and made sure that we also understand like some aspects of the preparation, like I've mentioned here, we can jump into actually rigging this arm with AdonisFX to achieve the final results of the rendered skin with all of the components and also showing the torsion on the forearm, for example. Hello, so today we're going to show you how to rig an arm inside of Houdini using AdonisFX. We have here a scene prepared with all of the elements that we need to rig this arm. Let's go inside of the arm geometry here, so inside of the group. You will see that we have here the mummy, for example, that is skinned and animated, and that we're going to use mainly as the target. So here we have separated each muscle entity in a separate geometry, and here we have already prepared the network in a way that will then allow us to transfer it back to Maya. So here we're going to start off with the brachialis muscle. The first thing that I'm going to do is just drop down an ADN muscle node, and I'm just going to use the naming convention that I have right here. So it's L_brachialis ADN muscle. This is a naming convention that you can adhere to or use any other naming convention. So here I'm going to first add the target. So we come to the target section of the node. But firstly, I'm just going to quickly show you that when you drop down a node, some default parameters will be used, and the start time and pre-roll time will be set to the beginning of the frame range. So that's where we always have to rewind to reinitialize the system. Now let's go back to the targets. And like I already showed you earlier, here we have the mummy geometry, and we're going to use that one as target. So we can just drag and drop this sock path right in here, and we can come back to the brachialis muscle. So as you can see right here, this is not doing anything yet, and that's because we actually have to paint the maps to attach it to the mummy geometry. So we can select this node, come to AdonisFX, and press Make Paintable. And what this essentially will do is it will populate an attribute paint node with the paintable point attributes that we have for AdonisFX. So we know that the first attachment that we had was the attachment to geoconstraint 0. So what we're going to do is we're going to just flood this to a value of 0.3. So let's do that right here. And then we can use a value of 1 on the extremity, so in the insertions of the muscle. And yeah, right here. Great. So now we can already play this back and see some results. So you can see right here, it's already simulating. Let me play back the full frame range. We can then, of course, tweak some parameters to make it more loose, and other parameters to control the overall dynamics and shape of the muscle. Great. So now, as you can see, this gives us the dynamics that we would expect when attaching to the target. However, we want to probably contract the muscle with some mechanical properties of the actual rig. So what we're going to do first is we're going to come back to this node right here, and we are going to paint the tendon weights. So we're going to paint the tendinous area right here, and we're also going to paint the tendinous area right here. And then we can come to the actual debugger of this node right here, and we can see the muscle fibers. Let me increase a bit the scaling, probably like a value of 10 is fine. And here you can see those fibers being drawn in the viewport. Great. However, we want to probably align those fibers with the actual edges of the mesh. For example, here, let me use smooth wire shaded. And yeah, we are going to align those fibers to the actual fiber direction that we would expect. So let's select the muscle. And in utils, we have the make groomable option. And you will see that here we have an HDA where we can actually trigger the fiber flow. So here the fiber flow has been generated, and we can start grooming and combing those fibers to be aligned in the proper direction. So here, something like that. And yeah, it should give us a better activation value than what we had before. Great. It doesn't matter if some fibers are pointing in one direction or the other, it's just that they should be aligned with the actual edges of the mesh. So let's exit this view state, and let's come here to the muscle. Let me put it back to smooth shaded, and let's play back one frame and come to the solver properties, and I'm just going to activate this muscle, and you can see that it's currently activating. Great. So now with the activation in place, we probably want to enforce some mechanical properties on that activation because we have just modified it with the slider. So what we're going to do is we are going to drop down a sensor, so sensor distance. And in this case, the sensor, we are going to call this in a way that makes sense for us. So elbow flex, 80-inch sensor distance 1. Let's remove this one, and then we have the locator. So let's use a locator distance in this case. Actually, let me rename this properly. Flex, and yeah, this the same for the locator distance. Great. So now we can connect this in this way. However, this will not draw anything yet. So what we have to do is let's just pin, for example, the locator here. And we are going to select on the object level the corresponding transformation matrices. So this is a representation using rivets of the KineFX rig. You can, of course, use your FBX import to bring in the joints, but it's very important that for AdonisFX, the joints or the rivets or the transformation matrix that you are going to use are on the object level. So we are going to use the shoulder joint, so we can bring this in here, and we are going to use also the elbow joint, so here. Great. So now let's come back to the subnetwork, and you will see that now we have this locator being drawn. And what I'm going to do is I'm just going to paste this into the actual sensor itself. So we have to replicate the same connections. And I'm going to increase a bit the width, the scale of that locator. Great. So now you can see that this is not doing much, and that's because we have to enforce the ranges. So we can come to the sensor. Let's go to the output pane, and in using the out distance, we are going to populate the input min distance with this value. And whenever we want to activate the muscle fully, which would be this one, we are going to use the output value right here and populate it in the input max distance. So now you can see this locator is being driven by this activation. And very important, if we come here, you can see that it's actually driving a detail attribute that we will be using to ingest the data inside of our nodes. So in this case, we are interested in the ADN activation distance. So that's what we're going to use. Great. So now what we can do is, instead of just driving directly the activation using an expression, we can actually use the activation layering system that will allow us to merge in multiple activations into a single muscle. So let's put this to 1, and that will add a new entry to the activation list. And actually, let me rename this. Sorry, this should be elbow and elbow. So we are going to connect the locator, so that will also output the detail attribute to the actual muscle itself. So the way that we can do this is that we are going to use detail expression. So we are going to use the full path, or you can use a relative path also. And yeah, we are going to use this one right here. And then we're going to use ADN activation distance and 0. Cool. So that essentially will drive that activation value. Let me put this to the side. And you can see in a second that when we animate this muscle, that it will start to contract with that activation value. Now let's have a look at how we can rig the tricep muscle. So let's go to the geometry right here. And we can drop down in ADN muscle format right here and give it a proper naming. So let's use L tricep right here. Then as before, we can start painting the attachments. So first what we have to do is we have to actually add the attachments. So let's come right here to the targets, and this time we are going to add 2 targets. We are going to add the shoulder, and we are going to add the actual mummy arm. So let's bring in the shoulder, and let's bring in the arm right here. And now we can make this paintable. So let's come right here, make paintable right here, and let's start painting these attachments. So the way that we're going to attach this is that we are going to come to attach to geo, and let's flood this to a value of 0.3. Okay, so we're going to first do that for the full arm. So let's do like that, like this. And then here we are going to use a value of value of 1. And we are going to paint this area right here. And we're also going to paint this area right here, so we preserve that landmark that you have right there. Let's do something like this. And now we are going to remove the weights on this area right here because we are going to attach it to the other target. So let's paint this like this. And now we can go to the other attachment. So attachment to geo constraint 0. And we are going to paint this first with a value of 0.3 in this area right here. And then we are going to paint to 1, just this area right here. Great. So now we have added the 2 attachments. Now we can have a look at the muscle simulation, and you can see that, yeah, we have the tricep simulating and attaching to those 2 attachment points. Great. So now what we can do is we can also paint the tendons. Let's come here to the tendons and let's have a look at that painting. So let's paint this area right here and this area right here, and then this area right here too. Now, as before, we can come to the muscle. We are going to do the make groomable option right here. Let's reorganize this a bit. And now we can start combing those fibers. You can see that this, in some cases, due to the topology, is quite erratic. And so we are going to just use the smooth white shaded option. And we are just going to align the fibers in the right direction, following the flow of the edges. We really want to avoid fibers that are not really aligned with the actual flow of the edges, because that may cause some unexpected behavior on the activation. Great, so we have that pretty nicely aligned. So now if I come to a different frame, so come to the solver, one frame, and now I can start activating this muscle right here. Awesome. So now the thing is that we are activating this quite uniformly, but that's not essentially how a tricep would work. So we can come back to the attribute paint node, and we're going to paint the fiber multiplier map. So let's go in here and let's use a value of 0. So we are going to come to smooth white shaded, and we're just going to paint the areas that we are not going to simulate the muscle at all. So removing the fibers essentially. So there will be simulation, but we are removing the fibers. So the contraction just happens in a certain area. So here we can remove this area right here. So let me remove all of this. And then we also want to remove this area right here. Great, something like this. And then we also want to remove this area right here, as these are tendon areas which shouldn't be contracting when we are activating the muscle. So yeah, maybe something like this. Great. So now if I come back to the actual node itself and I play back one frame and I activate, you'll see that the tricep will just contract in that area up there, which is the expected behavior. Great. So now what we can do again is we can maybe we can actually just duplicate this setup right here. And we are going to call this elbow extend. So, and the same here, elbow extend. And we can remove this and this. So now we are going to use different attachment points. So again, the locator, let's toggle this. Let's go to object selection mode. And yeah, we're going to select this one right here. And we are going to select this one right here. Great. So that will be elbow 3. So now if we select this locator right here, you will see that, yeah, it's aligned with what we have just currently selected. So now we have to estimate the actual activation value, but first let me copy this value into the right sensor. So here we are going to just put this in here inside of general, and this one too. Great. And now the same thing, we have the output value. So let's go to the start frame. We have here the maximum extension. So this should be here. And then we are going to see the maximum contraction. So here. And we set it here. Okay. So you can see that here, when the muscle contracts, when the mechanical properties come together, we are actually activating this more than before. Great. So yeah, actually, let me put this like this again. So now we are going to actually drive the activation of that tricep. So here, again, come to the activation layer, and we're going to add one entry here. And we're going to use the name that you have right here. And we're going to say detail. And again, here we can use the relative path. And we are going to use ADN activation distance 0. So this will drive now the activation. So you can see now it will be fully activated. And when we are in this pose, we are not going to activate the muscle. So let me just quickly show you this. So you can see there that the tricep is contracting whenever we bring this together. And yeah, now we are going to go to other muscles on the forearm to complete the rig of the arm inside of Houdini. So what we can do right now is we can rig some of the muscles on the forearm because the bicep brachii will lay on them. So here, let's just have a look at the muscles that we have to rig now. So here, the first one that we have to rig is essentially the pronator teres. So actually, this is the one that we have right here. So as before, create an ADM muscle node. Let's give it a name that makes a bit more sense. So here, pronator teres, ADM muscle. Let's remove the one from the end. And now we are going to add the first target. So let's add the target right here. And as before, the target will be the mummy geometry that we have here. So let's just drag and drop that right in here. And now we have to paint the attachment weights. So we can come here to make paintable. And yeah, we are going to paint the attachment to geometry constraint weights. So let's set this to a value 0.3 baseline. So let's just flood this on the whole muscle, and then we can use a value of 1 on the areas that have to attach to the actual bones. So here we paint this area right here, and we also paint the area right here. Great. Then if I simulate this, you can already see that it is attached and simulating. Now we still want to paint the tendon weights, so let's go to the tendons. Let's paint this on this area right here, and also on this area right here. Then we can come to the make groomable utility. So it's very important that we apply this ADM fiber groom after we have painted the tendons, so it actually picks up the initial fiber directions. So let's go to here, make groomable, and let's just sort this out a bit better. And we can come now here. Maybe for this muscle, we can just reduce slightly the fiber scale. And yeah, you can see that maybe in some areas, depending on how we have painted the tendon weights, the flow of the fibers is not really aligned with the actual edges of the mesh. So yeah, we just make sure that everything is properly aligned. And yeah, this looks already good. So now if we come to the muscle and just play back one frame, we can play around with the activation value and it will activate. Now, the thing that we want to actually do right now is we want to actually control the pronation. So we essentially are going to connect the two of these joints. So essentially these two. So as before, I'm going to just duplicate this setup right here, and let's call this left arm pronate. And let's also call this left arm pronate for the locator distance. Great. So now we can pin this again like before. Let's pin this one, and we can come now to the object selection. So let's go one level up, and we can use this one right here. This would be the elbow. And then we have another helper joint here that we are going to use to actually, let me drag this properly in here. Yeah, now. And let me just double check that this one had also been added properly here. Yes, great. So now we have already this activation. However, we want to modify and modulate this only when we are at this distance. So we can come here to, again, this setup right here. And we are going to set the same values on the actual sensor. So let's set this right here and also this one right here. Great. So this would be the maximum activation value that we can achieve. So here and the out distance, yeah, this is the input min. So let's use this value, and actually it should be the other way around. So here, and yeah, in this case, in this scenario right here, or even this one, we want to use this value as the input min. So you can see now, pronation will only happen in this region right here. Great. So now let's rename this properly, get this name, and we can go over to the pronator teres. We can come to the activation layers, add one single activation layer. And as before, we're going to use detail, use the name of that locator. And we are going to use ADN activation distance, which is a detail attribute that's coming from that sensor. So let's just check this out. And if I play this back, you can see that now that pronation will happen more reliably. So let's come here to the view and let's see how this activates now in this case. You can see there, it's activating in this position. So the next muscle that we are going to tackle is actually the flexor digitorum. So let's have a look right here to this muscle. So as before, we can come in and create an ADN muscle node right here. And we are going to copy over this name. Great. Now we can add the target. So again, one single target entry here. We're going to use the mummy arm for that. And now we can actually start painting the values. So here, make paintable. Let's organize this a bit better here. And we're going to paint the attachment to geo constraints. So let's use a value of 0.3 for the whole mesh, like this. And now let's use a value of 1 for this area right here. And this area right here. Great. Now we can also paint the tendon weights right here, and on the top area. Then we can come here and select the node, probably exit the view state, and here make groomable. So here we can, just start grooming the fibers in that direction properly. And that should essentially be it. It was quite aligned already. So let's just use the camera view. And if we now go to the muscle and we play back one frame, you will see that we can activate this muscle already. Great. So now the next thing that I'm going to do is I am going to create a sensor. So we are going to create one for the finger. In this case, we're going to call this fingers flex. Flex. And we are going to use the exact same naming convention for the locator. Remove this one here. And now what we're going to do is we're going to do the exact same thing that we did before. We pin this window, selection, object selection, and what we're going to do is we're going to click on this one right here, which is the wrist, and we're going to just drag and drop this sock path in here. And then if we select this one right here, we also drag and drop this in here, and we should already have our locator set up. Great. So now what we can do is we can unpin this window and we can just copy and paste the same values over to the actual sensor. Great. And as you can see in this rig, we do not have a way to, let's say, properly animate that region because this rig doesn't have animation on the actual fingers. So what we're going to do to configure the sensor is we're going to come to the rig pose node that we have right here. Going to select 1, 2, 3 joints. Let's curl this in this direction, for example. And that's what we're going to use for reference now. So let's come back to our ADN locator. Let's cook this once. And essentially this is what we are going to use as value for the out distance. So this should be the max distance. And now what we're going to do is we're going to just remove that key on the rig pose node. We're going to cook once. And now we can come back to the sensor and use this value as the input min distance. Great. So yeah, that will activate whenever we now use the animation on the rig, which will actually deform the bone. However, there's another one that we can add now, which would be the wrist flex. So let's do that right now. So let me wrist flex. Let me remove this one. Let me copy this name over here. Great. And now we have to do the exact same thing as before. So we are going to just select the locator, go into object selection mode. And as we want to rig this region right here, we are going to use this joint right here. So as before, get this in here. And then we are going to use this one right here, which is the one for the wrist, and paste this in here. So for reference, let me go back to the arm group. Here, if we check out the flexor, you can see that this aligns pretty well with the region that should be activating with this sensor. Great. So now I'm going to just copy and paste this over to the sensor. Wrist. Great. And now we can actually change the values, the ranges. So this essentially would be our min distance. And then the maximum would essentially be right here, I think. Something like this in this area. So here we can come and bring this value right here, and that's where we would get maximum activation. Great, so now we can attach both of these sensors to the actual muscle. So we can come and bring this name over here. And we can come to the activation layer. We're going to create two. So the first one would be detail. And paste this in here. And we are going to use ADN activation distance 0 as our driver. This one was for the finger. It's not going to do much because we do not have animation on that one, but we can now, even from here directly, press detail, and we are going to use the wrist, where is it? Wrist flex locator. So this one right here. And we're going to use the same ADN activation distance 0. And you will see that you can also use different outputs from the actual sensor locator, which you can use then to drive your activation of the muscle. You can see there. Now, if I cook this node, so this muscle, you will see that if I play this back, it will start to activate in the right poses, opposed to how it was before. So yeah, this could also have been a good example for maximum activation here, but yeah. So the next muscle that we are going to actually rig is the palmaris longus. We are going to use the flexor digitorum superficialis as the target for this muscle. So we can come here to ADN muscle, drop this down, and we can use as target the output of the deformed flexor. So here we can come and use this null node to actually speed up things instead of just pointing directly here, because it's better for the API support. And now we can start painting this muscle. So here we can come and make paintable. And we can come here. And we can start painting this attachment to geo-constraint weights to 0.3 as before, flood. And now we can use a value of 1 in this area right here. So here, and also a value of 1 right here. Great. So now this should be attached to the other muscle. Let's see how this behaves. You can see there, it's contracting together with the extensor digitorum, and we can also add the activation value that we had on the flexor. Sorry, I was saying extensor digitorum, it's flexor digitorum. So yeah, let's just copy and paste this value right here over, and we can go to the palmaris longus and come to the activation layers right here and just paste this in right here. So the rest flexion, which essentially is this one right here, you can visualize this too, is going to control also the activation of that muscle per se. So far, if we cook all nodes, let's have a look. Yeah, we would get something like this so far. But yeah, there are still some muscles that we have to rig. So let's continue with that right now. So just one extension of the palmaris longus, I forgot to paint the actual tendon weights. So let's go back there and just paint quickly the tendon weights. And actually, let's add proper fibers to this muscle. So like this. And as before, I'm going to select this node, come here and make groomable. And yeah, we can come in the view state and just align a bit more the fibers to the flow of the actual muscle. Great. So that looks already pretty good. And now we can essentially now see the proper activation happening. Because before it was actually just mimicking what the underlying muscle was doing. So yeah, now we have painted properly the actual fibers for this muscle. So now what we can do is we can start working on the bicep brachii, and you can see right here the muscle. And this muscle has the peculiarity that it will have several other attachments. So here it will not just have the mummy geometry, it will also have several other muscles that we are going to use as the targets. So in this case, let me just have a look at the different targets that we have. So here we have the shoulder geometry, we have the arm geometry for the mummy. And then finally, what we are going to do is we are going to actually use the brachialis. So let me just have a look where that one is. So down here we have the brachialis. Then we also have the palmaris longus. So here, let me just template that one too. Then we have the, let me check. We also have the pronator teres. So that one is also going to be involved. And then finally, we have the mummy and the mummy shoulder. Great. So let's just have a look at how we're going to attach this now. So we are going to come here and, as usual, create an ADM muscle node. Place it down. Let's use a proper naming convention right here. So let me just double check the naming. So yeah, here, of course, we have to go back probably and just rename this to the right naming convention just to make sure that everything is correct. So let me just put this to palmaris longus and using the right naming convention, and the same here. So place this down and the same with this node right here. Great. So now we have fixed that from the previous setup that we had. And I'm going to now paste in the name of the bicep brachii right here. Let me remove this number. And now we can start adding the different attachments. So we are going to attach five targets here. So let's add 5 entries. The first entry that we are going to use is the mummy shoulder. So this is the one that we have right here. So let's just paste this in. Then the second one would be the mummy arm. Then we would have the brachialis muscle. So we're going to use the output of the solving for this. So here, if I remember correctly, it's there. So here we have the brachialis. Then we are going to search for the pronator teres, which you will find, check up here. So this one is going to lie flat on one of the extremities of the bicep. And then finally we have the palmaris longus, which is the muscle that I've just fixed the naming for. So we can come here. Let me just select the bicep brachii here and paste in the palmaris longus. Great. So now we have these 5 targets, and now we can start painting the different attachment points. So what we can do to ease a bit the setup process is we are going to just template the different muscles that are involved. So here we have the brachialis, then we have again the pronator teres, we have the palmaris longus, and then finally we also want to check out the mummy shoulder. So these are the muscles that we're going to use for the rigging process. Great. So we can come here, let's make it paintable, and we can start painting the different maps. So we have to remind ourselves the order in which we have added the different targets. So here we are going to use the attach to geoconstraint 0, and that will be something that we are going to use to attach to the shoulder area of the mummy. So let's use a value of 0.3 right here. So we're going to paint up to this area right here. And then we can use a value of 1 for the tip. Great. Now we can go to the next map. So let's have a look at the second one. And the second one will be the one that we are going to use to attach to the actual mummy geometry for the arm. So in this case, actually what we can do first is probably let's attach the brachialis, because that's one of the main components that are going to drive the simulation. So let's come right here. Let's set a value of 0.3 for the whole muscle. And then we are going to remove the upper part and the bottom part. So let's set this to 0, because that's what we're going to use to attach to the actual mummy geometry. So here, I'm going to remove this area right here. So it's aligned with the actual brachialis that we have underneath. Right here. And then we're going to do the same thing for the bottom part, because that's where we're going to attach to other muscles. Great, so now we have the brachialis. Now I already painted the one for the shoulder of the mummy. And now I can go in and paint the actual mummy geometry, so the mummy arm. So in this case, I'm going to use a value of 0.3. And I'm just going to paint this area right here. That's going to be attached to this arm, making sure that we do not overlap much with the map that we have created for the brachialis. So in this case, yeah, it's pretty good. So come here, so something like this. And then we are going to attach fully also the bottom area. So in this case, this area, we also want to have it lying flat on the arm geometry. And yeah, we can now use a value of 1 to just paint the extremities, and the same will happen on this area right here. Great. So now we have that. And now we can check out the muscle, the other muscle that we have. So for example, here we have the pronator teres, which will be down here. And then we have the palmaris longus. So let's just paint here. Let's go to the attach to geoconstraint number 3. And this is the pronator teres. So we are going to use a value of 0.3 for that one. And it's going to go right over this area right here. And then finally, we also have the palmaris longus, which we are going to paint to 1 in this area right here. So, something like that. Great. So let me just play this quickly back and see the results. You can see there we are attaching everything as we expect it to be. And yeah, now we have the bicep rigged against the brachialis and also the components of the mummy geometry. Great. So now the next thing that we have to do is we have to actually activate the muscle. So we have to paint the tendon weights. So we can come here, as usual, paint the tendinous areas. And then we can come in here and paint this. And then as before, we can also make the node groomable. So we can come here and make groomable. And now we can come into the viewer state of the fiber groom node. And we can start aligning those fibers to the actual proper fiber direction of the muscle. Like this. And yeah, should be it. And now if I come to a different frame and go to solver, we can activate the muscle. However, we may want to just bulge the muscle in this area right here. So what we can also do is come back to the attribute paint node, and we can use the fiber multiplier. So in this case, I'm going to remove the fiber multiplier in this area right here. So we essentially just want the muscle to bulge in the head of the muscle while it contracts. So let's just paint this like this. And yeah, we can also remove, for example, here, this area. So it will bulge just in this area right here. Great, so something like that. And now we can come back to the node itself, press 9 key, and yeah, we are going to just activate the muscle. As you can see, it will only pull in this area right here, which is what we essentially want. Great. So now we can actually come to the brachialis muscle again, and we can actually reuse the expression that we had for the arm elbow flexing. Well, yeah, in this case, it's the elbow flexing. So that's what we're going to use for the first activation value. Let me just make sure that it's the right one. Yes, exactly. So this is the one that we want to use also to activate the bicep. So you can come here to the activation layers, add a new entry, paste this in, and yeah, let's have a look at the cooking. So you can see that now the bicep will actually contract whenever we have that sensor firing. Great. However, this is not generally how the bicep only works. We had actually added the pronation on one side, but now we also want to activate the muscle using the supination, which is between these two joints that you see right here. So what we can do is let's come here and duplicate this one here. So a sensor and the locator setup. And we are going to call this arm supinate. And we're going to call this also arm supinate. Great. Now we have to do the thing that we did before. So we can come here to the locator. We're going to pin this window. And we come to object selection mode. And we essentially want to use this one right here. So let's drag this in here. And we also want to use the elbow in here. Great. So now we can come here, visualize this, and as before, we are going to just copy and paste the values inside of the sensor. So in this case, for this position right here, we want to actually have like the rest state. So this will be the actual input min distance. And then whenever the muscle does something like this, That's good enough. We can use the out distance to define the max distance. Great. So now we have the supination. So now what we can do is let's just copy this name over. As you know, this will output a detail attribute on the activation distance. And we can come to the bicep brachii. And what we want to do is that, given that we don't want this just to affect the muscle, we can add a new layer. And let's add a value of 0.6 and use an operator that is multiplication. So the activation that is coming from the actual arm flexing will be multiplied by 0.6. And now what we can do is we can use another detail expression, something like that, and use ADN activation distance. And yeah, and now we have both of those activations contributing to the overall activation of the bicep brachii. So we will see that now when the muscle flexes, we have activation. But then whenever we have that supination, you can see that then the bicep is also activating, contributing to the overall activation of the muscle. And yeah, that should be it for the bicep. So now that we have rigged the bicep muscle, we can have a look at all of the muscles that we have currently rigged. So this is the setup that we have. And of course, it might be that the muscles are a bit too jiggly, and we can work on that later, as we also need to add slide of geometry constraints that will keep everything more together. So now what we have to work on are the rest of the forearm muscles. So in this case, we are going to start with the extensor carpi ulnaris. So let's have a look where that muscle is. So extensor carpi ulnaris, okay, this one. So yeah, as usual, we are going to create an ADM muscle node, and let's not forget to add a proper naming convention. So let's take this here. And we are going to use, for all the nodes that we are going to rig right now, we are going to use the mummy geometry as the target. So let's come in here in the targets pane, and in the target world mesh, let's add the mummy arm. So we can drag and drop that in there. And now we're going to start painting the different values. So here, select this muscle, let's make it paintable. And now we can start painting the attachment weights. So as usual, let's use a baseline of 0.3, and let's just paint the whole muscle with that value. And now we are going to use a value of a value of 1, where we really want to attach the muscle to the arm. So something like this. And yeah, we want to attach this a bit more up here. Then to estimate an initial fiber flow, we can come here and select the tendons. So let's paint the tendon weights right here to get proper fiber flow. And then we can come here and we can come to the fibers multiplier, and we are just going to reduce the areas where we do not really want the fibers to contract the muscle. So something like this. Great. And of course, we can then go and select the muscle and quickly make it groomable and see how the fiber flow is working. And in this case, it's pretty good, so I'm not going to touch that anyways. Great, and you can see that now this muscle has also been rigged. Great. So now the next one that we're going to do is the extensor digitorum. So we have here this node right here. So let me just check that out quickly. The extensor, so here we have the brachialis. Yeah, here we have the extensor. So we're going to create an ADM muscle node right here. And the same as before. I'm going to copy in the name here, just for naming convention. And now we can have a look at this node right here. So the first thing that I'm going to do again is to use the mummy as the target. So come in here And let's try to paint this a bit faster this time. So here we can make this paintable, and we can come to the attachment to geoconstraint 0. It's very important that you add the targets before making it paintable. If you make it paintable after adding new targets, it will refresh, but ideally you should add the targets and then make it paintable so the maps will appear right here. And each entry maps to the entry that you have inside of the targets pane. So that's very important for when you want to update your real rig. If you want to add new attachments, you will have to add the target and then make it paintable again. So we're going to use a value of 1 for this area right here. And yeah, just paint all of this area right here too. Fully attached. Then we have the tendons. Great. Something like this. And yeah, this is fine right here. Then we are going to paint the fibers multiplier. We don't want this to affect this area right here. Okay, great. And now we are going to just check out the fiber flow. So make this groomable and enter the view state. And you can see that, yeah, it's pretty aligned. So I'm not going to touch this for this muscle yet. Great. So now we can play this back, and you can see that this muscle is also rigged to the arm geometry. Great. Now the next one is the extensor carpi brevis. So this muscle right here. So the same thing, ADM muscle. And maybe what I can also do now is I'm just going to copy and paste this over as we have the same target. And I'm just going to rename this node. Score. Great. Let me just make sure that this is properly named, because sometimes when copy and pasting, it is not picking up the right naming convention. So yeah, this is now correct. And yeah, the same drill. Now we have already the mummy here, so we can make this paintable. And we are going to use the attachment to geoconstraint 0, flooded to 0.3. So let's paint this like this, and then again, the insertions right here, and something like this. Great. Now we have also the tendons that we can paint. We should paint to get the activation, and yeah, something like this. And then also the fibers multiplier, just to make sure that we do not activate in certain areas, so we can do something like this. Great. Now let's just check out how the fiber flow is working here. Make this groomable, enter the view state, and yeah, here we do probably want to do some adjustments to the fibers, so let me do that quickly. Right here. And yeah, right here. So yeah, that's more aligned with the fiber flow. Great. And yeah, let's have a look at how this behaves. See, this is rigged. And as you can see, these muscles, like especially the ones that I'm going to show you now, are the muscles that are more tricky to rig, because you have the torsion of the forearm and also the flexing of the arm. So this will be the extensor carpi longus, the next one that we're going to rig. And let's do exactly what we did before. Let me just copy and paste this node right here. So duplicate, because we have the same target. And let me just paste in this name. And now I'm going to make this paintable. So again, a utility to ease the setup. Like I said, what the user can do is to actually copy and paste the values over to an attribute paint node, but that is a bit more cumbersome. So yeah, just going directly and making it paintable will speed up the process. So here, 0.3, and let's have a look to the view state. And yeah, let's paint this to 0.3. And now let's use a value of 1. Down here, and let's use a value of 1 in this area too. it's attached to the arm. Then again, the tendons. And you can see that I'm going over this quite quickly, but yeah, we will refine the setup afterwards. And then we have also the fiber multiplier, which I'm going to just reduce in this area right here. And then finally also in this area right here. Great. So then again, we can come here and make it groomable, and we can check out the fiber flow. So in this case, yeah, we can do some small adjustments, but overall the fiber flow is quite aligned with what we would expect. So here again, the next muscle, and yeah, you can see that maybe in some areas we have to do some adjustments. So maybe what I could quickly do is, let me come into the attribute paint node. Again, let's go to attach to geo, and let me just reduce a bit. Let me use a value of 0.3 here. And yeah, let's use a value of 1 just in this area. But yeah, we can refine this later on. Just wanted to make sure that I've attached this properly. So here, and yeah, it's a bit better now. But anyways, we can refine that later on with some proper painting. And now finally we have the, we will leave delta for last, but we have the brachialis. So here, let me, which one? We have the carpus longus. So this one, let me copy and paste this node over. So we have the brachialis, and yeah, here we're just going to make sure that the naming is correct. And let me just go back here. Let me make sure that I removed the trailing number. Yeah, the indexing. So now we have again the brachialis, and we can come here and do the exact same process again. So here, come to attach to geo, set the value to 0.3. And set the value to 1. And yeah, let's attach this area right here. And also this area right here. That lies right on the bone. Great. So now we have also this painted, and now we can go ahead and paint the tendons. So again, something like this quickly, and yeah, something like this right here to mimic the fiber flow. And then again, we can go ahead and paint the fibers multiplier, set the value of 0 on this area, something like that. And yeah, also this area right here. Brilliant. So now we can check out the fibers again. Great. And let's check out that fiber flow. So yeah, it might be that we have to increase a bit the scale, especially for this muscle. And yeah, you can see here that we can align this further, but yeah, it looks like it's pretty good already. Great. Press 9 key and come out of this. And yeah, you can see now that this one has also been rigged. And if we now check out all of the muscles together, I think I've not left any muscle out. You can see that, yeah, we have all of the portion of the forearm rigged, but of course then we would have to, yeah, do some adjustments, because in some cases the muscle are just too loose. And actually, let me drop down a normal node here just in case, so we can check out the computed normals. Let me put it on points. So yeah, you can see there the result of the first pass of the arm. Of course, we still have to add some sensors to the forearm muscles, but overall, we have already rigged the arm in a way that will allow us to have a look at the simulation. So before moving forward with the rest of the forearm, I just wanted to quickly show you that I wanted to tweak the sensor of the tricep because it wasn't doing the right thing. So actually, let me come here to the elbow extension. So in this case, I rigged it in a scenario in which we had the rest activation in this state, but ideally we want to have the rest at this position right here. So what I'm going to do is I'm just going to use the out activation value here and bring it into, here, this value. So this is the minimum value. And then essentially what we are going to do is we are just going to have the maximum activation in this pose right here. So we can come to the output, set it right here. And and now we can actually see that it will activate in this position right here, not between this and this. So I'm going to just have a look at all of the muscles right here. And you can see that now when I play back, this is more stable and it will activate whenever the tricep activates in this position right here. So now after having configured the forearm without the sensors, we are going to create some extra sensors to be able to drive the activation of the forearm muscles. So now the first one that we're going to create is actually the wrist extension, so the extend. And here we're going to use the wrist flex. So let me just duplicate this right here. Let's call this wrist extend. Great, and do the same thing for the locator. Great, and now we can start configuring this properly. So as before, let me go to the locator. Let me pin this window, and we can come in here, and we're going to select first this joint right here. So this one right here, you can drag it in this section right here. And then we are interested in this one right here. So joint number 1. So we'll bring this in and that will be actually the flexion. Great. So with that configured, we can configure the ranges. So let's go inside of here. Let me hide this. And we can bring in the same joints to the actual sensor to be able to get the values. So bring this over to the sensor. Great. And now this will be the rest. So the out distance would be this one for the minimum value. And let me go to a pose where character does something like this. Of course, we can pose this properly and get the maximum extension. But this should make sense. And we can put this into the input max distance. So you can see there that when the arm does this, it is activating that value. Great. So that is the first one. And then we're going to reuse the one for the fingers. So the finger flex, we are going to do the actual fingers extend. And right here. And here we can see that this is how it was configured before. So we have to actually move just one of these attachment points to the other side. So again, in this window, and we can come here and we will change the one of the wrist. So here, select this one right here. And, this one, and bring this one right here. So wrist number 2. Great. So that's something that we already have. The thing is that we do not have any animation on that bone. So what we can do is we can come to the rig pose node right here. And we are going to just move this finger in the right direction. So maybe something like that makes sense. So let's go over to the actual sensor locator setup. Let's recook the setup. And that's what we're going to use as our maximum value. So let's just make sure that we have also copied over the right value here. So this would be wrist 2. And here the out distance, we're going to set this to the min distance. And now I can remove that rotation that I have on the rig pose node, here. And cook the setup again. So that will update the actual sensor right here. And we can come to the output value. And we are going to set this into the max distance. Actually, let me double check that one. Just rewind quickly. So let me just make sure that that is correct. So here we have the output. Okay, so that's actually the max distance that we want to use, And here we can just bypass this rig pose node, cook it again. And yeah, that's now the one that we're going to use as the rest pose. So the minimum distance. Great. So now it's working. Now for other muscles, what we're going to do is we're going to configure the abduction and adduction. So we're going to first work on the adduction, and essentially it's between this joint here and this joint right here. As you can see, this one will remain static up here, and this one is the one that's going to rotate. But essentially, we want to mimic the movement from side to side. So here, I'm just going to create one from scratch. So this setup can be copied over, and let's call this wrist abduct, and the same for the actual locator distance. Great. So now, like before, we can pin this window, and we can come to the object selection mode, select this one right here, and bring in the wrist, and bring in here the elbow. Great, so that has been already created. And now we can configure the ranges. What I'm going to do now is I'm just going to create also the adduction quickly. So this would be adduct, and bring this over to also the locator. So like this. And this one changes a bit like before. So let me just pin this window, and we can select first this wrist, and we can select this joint from the elbow too. And that should be it. Now, of course, I have to bring the values into the actual sensor for this to work properly. So go to general, and we go here for the elbow. And we are going to do the same thing for the abduction. Bring the elbow, and like this. Great. So now we can just use those rest values as the input. So for example here, let me use the out distance into the input min distance, and the same here for the other one where we have the out distance being the input min distance. Great. And now what I can do is I can come here to the rig pose node. I'm going to just delete this transform, come into the viewer state, and let me use this wrist rotation just to, let's say something like this is good enough. So we can come back to our setup right here. Not this one, but this one. And this will be now my new range. So here we can come to the out distance, and that's what we're going to use essentially. Sorry, I have to cook this one again properly. So this out distance is going to be our input max distance. Great. So now, we can probably just animate this, and it will output the correct value. And now what I'm going to do is I'm going to do the same thing, but I'm going to remove this value and do it for the other side. So for the adduction. something like this, and come here to the other node. Let's cook the sensor too. And then this value is what I'm going to use as my input max distance. Great. So now I can come here, remove this posing from the rig pose node. And here we can see how it will start to activate when hitting those poses. Might have exaggerated it a bit in terms of the animation, but yeah, you can see here that it fires when we have this kind of scenario right here. So now I'm going to show you how you can attach this to each muscle in the forearm. What I'm going to do is I'm just going to drop down here an object merge node, and let's just have a look at what the overall activations that we have inside of this for the sensors. So here what I'm going to do is let me use one as example, so locator. Actually, turn this off. Let me go and select this locator. And what we're going to do is just use a wildcard to select all of the located distances. Remove this and like this. Great. So that would give us already all of these sensors that we have configured. And yeah, of course, I also realized that this locator here, the sensor, we could also attach it to a different area. So instead of here, but yeah, ideally it should work like that. So you can see here all of those activations happening on that forearm. So let's go in order. Let's use, for example, let's see, the brachialis. Let me check where I can find that one. Right here. Great. And yeah, actually, this is the brachialis. Let me check the brachioradialis. Right here. Great. So this one will have 2 entries, essentially. We can also check out with the templating, which would be essentially the locators that we want to use. And in this case, we probably want the flexion. And we also want the adduction in this case. So, and this one right here. So what we can do is let's just check out the namings that we have here. So we want the arm flex, the pronate, elbow flex. Yeah, I think this one is the right one. So we want that one. So we can select this and bring it over to our muscle. And as before, going to the activation layers, adding a new entry and saying detail and doing this, and then alien activation distance 0. Brilliant. That's something that we have. And then we are going to use the, if I'm not mistaken, we want the abduction. So in this case, we could just copy and paste this over here. And this would be wrist. Sorry, wrist, left wrist, abduct, abduct. Great. So that should be firing accordingly. Then we can go to the next muscle. We want the extensor carpi longus. So let me see. Carpi longus. So there. Extensor. Yeah, so we want this one. Extensor carpi longus. And in this case, we are going to use 2. So we want also the flexing, the arm flexing like we had before. So let's go to solver, activation layer, and come in here. And yeah, like before, let's just type this in. So this would be L, so this would be elbow flex, and get the locator, and then we do ADN activation distance. Great. And now we can copy and paste this value again. And then what we're going to use for this muscle is we are going to attach the supination. So let's do wrist, arm supinate, and we have here the locator. And yeah, now we have both these values. We will go over the muscles in a second, all of them. So this is activating accordingly. Great. And now we also have the wrist extension that we will be adding together with the fingers extension to the extensor digitorum. So here, let's just check where that muscle is. Yep, right here. So here, again, we're going to add 2 entries to the activation layers. 1 and 2. And yeah, I'm just going to copy and paste some of these values in here. So here we said that we want the wrist extend. So come here, L, wrist, extend locator. And we said that we also wanted the one for the finger. So the finger extension. So fingers extend, locator distance. Brilliant. So here we have that activating accordingly whenever we do this movement right here, which is exactly what we want. And then finally, we have the extensor carpi ulnaris, which is this one right here. And if I'm not mistaken, this doesn't have any activation layers. And here we just want the adduction in this case. So here, let me just type this in again, detail. Then we're going to use the relative path. So L, wrist, adduct, this one. And we want the ADN activation distance detail attribute to be used in this setup. Great. And yeah, you can see now this is also going to be activated. And I think that's all for all of the forearm muscles. We can have a look at all of them together and play this back. See all of this activating whenever we are moving in the right direction, which will leave us only with necessarily needing to rig the deltoid, which is the only muscle that we are still missing. Now what we're going to do is we are going to rig the last muscle in the arm setup, which is the deltoid. You can see right here that I have not rigged this yet. So let's drop down an ADM muscle node and let's name it accordingly to the actual naming convention that we have applied from the geometry. And now we can think about the targets. So here we have the shoulder and we also have the arm geometry. What I'm going to do is just for the ease of this setup process, I'm going to come to this visualizer that I've created. And I'm going to add also the shoulder. So in this case, we have this already selected. And then we can have this visualizing while we rig the actual arm itself. Great. Which essentially can be from a different subnetwork, but ideally it should be all in the same network when we rig with AdonisFX. Great. So now we have here the deltoid, and we can add the targets. And like I already mentioned, we're going to use the shoulder and we're going to use the mummy. Brilliant. So now we can start painting. So let's come here and select the make paintable button right here, and we're going to start to paint this accordingly. So we're going to come here to the first attachment to geo constraints, which would be for the shoulder muscle. And we're going to paint this to 1 in this area right here. So come in here and just paint all of this area to 1. Great. And now we can go to the attachment to geo constraints, and we can use a value of 0.3 globally, except that we're going to just remove some of the paintings in this area right here because we don't want it to affect the muscle. So here, because we are using the other attachment as the driver for this region. And now we can go ahead and use a value of 1 just down here to attach this properly in this area. Great. And now what we can do is we can come and paint the tendons. Set this to value 1, so it would be here. And then we can start painting up here too. So that will dictate the original fiber flow, but here especially we need to be a bit more careful because of this muscle. And you will see at times that you have a warning here that there's non-normalized weights, and that's just that the solver will normalize those weights if they are overlapping, and the addition of the multi-influence weights is greater than 1. So it will do an internal normalization, but nothing to worry about because the system will still work. You can go ahead and refine the painting. So the vertices have never a value exceeding 1 when actually painting the attachment to geometry or sliding geometry, for example. Great. So now we can come to this node and we're going to make this groomable and come into the viewer state. And here you can see that, yeah, we have to actually align those fibers in a better way. So you can see right here. And groom those fibers, and yeah, that already looks way better. And this region looks quite good in my opinion. Great. So we're following the fiber flow of this muscle. Maybe here we can do a better job, but overall, yeah, this looks already pretty good. Great. So now we have the ability to just play this back and have a look at how this was attached. And yeah, you can see that, yeah, we're attaching muscle accordingly to its targets. We can then, of course, increase the amount of attachment in this area to avoid those penetrations, but I think this is already looking quite good. So now we actually have to create one of the sensors to be able to activate this muscle accordingly, which essentially we want to create in the arm elevation, which would be this movement right here. So we will actually want to create a sensor between this joint and this joint right here. So let's come back into the setup for the sensor. And let's call this arm elevate. Great. And now we are going to deduce the attachment points. So here, pin this window again. Then we come into the object selection and we want to do this one right here. So the scapula, and yeah, we want this one right here, which is the shoulder. Great. Nice. So now we can come back to the subnetwork and we are going to copy in the value from the actual locator to the sensor like this, and the same for the shoulder. Great. So now let's just visualize this. And yeah, you can see that the ranges are not correct. That's why we have to come here to the output value and bring it into the min distance. And then the max distance would essentially be something like this right here, I think. would make sense. And we can come and just paste in the out distance, and that would be the actual value that we want to achieve. Brilliant. So now we can get this locator, and we can come to the deltoid that we had, and we can come to the activation list. So here, and we're going to do detail and paste in the name. And now we are going to use the ADN activation distance. Brilliant. And let's just see if that value has been picked up properly. And yeah, it is. So now we can have a look at how this will activate under certain condition. So you can see there, the muscle is actually activating. And yeah, maybe we can actually, let's try out just increasing a bit some of those attachment weights that we have there. So let's come here, attachment to geo constraints, and let me put this to the side. Great. And yeah, let me just increase a bit the attachment to geos here in this area. And yeah, I think that's a bit better. We can then also maybe add some bit of smoothing, and let's see if this improves a bit the result. Let me check this out. So actually, see here, let me go to camera view, and yeah, it's improving. You can see that we are not computing the normals, so you might see this black area, but yeah, this works a lot better now. So we have here the deltoid activating properly. And now what we can do is that we can actually add some relaxation, because maybe we do not want this bulging to happen all too much in this particular in this particular pose. So we are going to add a relax node to the output. So let's use ADN relax right here, and let's give it a proper name. So we're going to use deltoid ADN relax 1. And yeah, let's set, for example, 4 iterations. And let's just cook this. And you'll see that, yeah, it's maybe a bit too much in this case for the relaxation. So what we are going to do is we are going to just add some painting here in some areas. So I'm going to make this one paintable too. And we're going to focus on the actual weights. So here you have the relax, here you have the weight painting. So we are going to paint here the weights. And yeah, ideally, let's set everything to 0, and we just want to relax in this area right here. So to be able to see the actual edges, let's go to smooth white shaded, and let's start painting just this area right here. So in this case, we want this to be fully relaxed, so the bulging is not so evident. And now what we can do is we can just add a bit of smoothing like this. Check out the relax node. And you can see that now, yeah, the relaxation is happening more uniformly. And yeah, we can maybe add a bit more of smoothing if we wanted to, so it affects more the muscle overall. But yeah, I think you get the idea of this. However, we might not want to relax always. So we just want to relax when we are activating. So let me go back to the smooth shaded, and we can copy the exact same value that you have here. So let's come and bring in this detail attribute here that we have for the arm elevate. And we are going to modulate the actual envelope feature too. So you can see here that the envelope is being triggered by the envelope of the relax is being triggered by the sensor too. So now we have multiple things affecting this deltoid. And if we check now everything together, let's have a look. Yeah, now we have also the deltoid rigged accordingly, but yeah, we can go in then and refine it further. I just wanted to give a first pass to that muscle. And yeah, seems to be activating in the right moment. And yeah, now we can move on to the next steps. So as an extra step, what we can do is we can actually focus, for example, on the forearm muscles right here. And you may notice that in some areas we are like increasing the gap between the muscles. So especially this one and this one. So maybe what we want to do is we want to add a new attachment to one of those muscles. And in this case, we are going to check out the brachioradialis, which is that muscle right there. So let's just have a look where we can find that node. Here, tricep, so exactly here, the brachioradialis. Okay, so what we're going to do is we're going to search for the actual muscle that is on the side, and that should be one of the flexor muscles. So here, let's just check out this one. And yeah, this should be the one that we are going to use to attach this. It's the flexor digitorum superficialis. Yeah, great. So now we can come to our node, brachioradialis, and we can add a new entry here. And we can drag and drop this in here. So you will see that here we do not have the entry yet to be able to paint this properly. So we can come here to the muscle and we can make this paintable again. And essentially what will happen is that now we have the updated entry. We will still have the original weights, as you can see right here. So here with have the attached geo constraints, but yeah, you can see that now we have a new entry. So every time we add a new entry here, it will populate when we make it paintable inside of the attribute paint node right here. And of course, this might be a bit cluttered at the moment with all of this values, so we can actually kind of separate this to make it more visually appealing. But yeah, let's go ahead and come in the painting here. So we're going to come to attach geo constraints. And what we're going to do is we're just going to use a value of 0.5. And we're going to just, let's say, attach this area right here to the muscle that we have there. And one thing that we can try out is that we can come to the muscle and we can actually debug this with the attach geo debugger. And you can see right there, maybe a different color will make more sense. And you can see that there we are attaching to that muscle in that area. So I think that looks pretty good. And now we can have a look at the results. And maybe everything together would make more sense. So come here. And yeah, here you can see that we are indeed decreasing the gap between those two muscles. And yeah, that's essentially what we want to achieve. Great, so now let's just check out other muscles. Might be that they are looking fine, but we could also, for example, attach this muscle to this muscle right here if we wanted to. And yeah, it would just lie on one of those muscles. But I think after the painting that we've done, that this looks pretty good and there's no collapsing in that area at all. Of course, we have to work still on the jiggly part of this asset, but I think now we can start moving forward with actually preparing to apply the fascia on top of this, on top of the muscles. So now in preparation to adding the fascia layer to the setup, we are going to mimic the deep fascia, which we can do with our Adian glue node. So what I'm going to do is I'm going to drop down an Adian glue node and we are going to give it a specific naming convention. And we recommend that we always use this naming convention also for the geometry because then the setup is exportable. So here I'm just going to use this ADN in. And we are going to call this ADN glue 1 geo. Let's call it geo shape. Then the one that we have on the output will be the same, but we're going to just call it out. Great. So now we can connect, let me disconnect this. And now one thing that we have to do is we have to actually set the right piece attribute. So you can see that here it requires muscle ID. But in this case, if we check one of our muscles, we had created a primitive path attribute. You can see right here. And that's essentially what we're going to use to distinguish each and every single muscle. Great. So now we can come here and we can firstly modify this to be path, but yeah, we can prepare this already, but ideally we can also select it when we have everything merged. And now we are going to select in order all of our null nodes here for the muscles. So here we are selecting all of these like this. And essentially that's everything that is going to be glued together. Great. So now we can just get the output of one of these and type in merge. And that essentially is going to be our merge geometry. So we can come here and we can actually put it probably to the side. So let me bring everything just down here to the side and make this a bit bigger. And here we can just connect this straight in here. Let me actually give it a proper name. So here we have ADN glue 1. This is going to be our glue shape. So this mimics what we have in other DCCs. And now we can bring this in and just connect this here and cook the glue and also the output. Great. So now you can see already that we are picking up the result of the glue layer from the muscles. However, now we have to actually give it something to actually glue the muscles together. We can come here to the debug pane and we can check on the debug option and glue constraints. Maybe give it a different color. And then we can come to the solver properties of the ADN glue node, which at the end of the day, we can also rename to a different name. In this case, we're just going to leave it ADN glue 1. Or we can add the shape name, but given that it's being generated like this, we are going to leave it like this. And now we can come to the advanced settings. We can come to the dynamic properties. And in the max glue distance, we can start increasing the value. So for example, let's say that we first start off with a value of 1. We'll create all of these connections that you see right here, but maybe it's not enough. So maybe we'll want to use a value of 2. And yeah, that looks like it's gluing everything together. You can also change here, you're pressing D in the viewport. You can actually change the wire width, but it will change it globally to the scene. So let's keep it to 1 and debug this in this way. So now if we play this back, you will see that the muscles are being glued together. We can actually check the difference by, for example, using the envelope feature. You can see that. So that is actually pulling the muscles together and it's also preserving the volume. However, maybe in some cases we do not want to actually glue the muscle together all too much in that area. So you can see there, maybe in this area we want to loosen it up. So what we can do is we can actually make this paintable too, like this. And we can start painting the glue resistance weights right here. So come in here and we can start just removing some glue resistant weights. So I guess we want to remove it in this area right here. And then we can go back and forth to the debugger to see what's going on. So for example, in this area right here, let me make it a bit smaller. Like this. And maybe up here too. And then maybe this area right here, we also don't want to this have effect on the glue resistance. So here, something like this. And then we can go back and forth to the actual glue node. And maybe up here, we also want to just remove that glue resistance. You can see that now that attachment point got removed. And maybe also this area right here. So yeah, let's just make sure that that gets painted accordingly. So yeah, there you have it. Great. So yeah, maybe even down here. So yeah, we can then go ahead and also modulate where we want the glue to happen or not. So you can see there. And yeah, in this case, we are quite aligned probably with what we want to achieve. And yeah, we have everything glued together, mimicking the deep fascia. And we can then go onto the next layer, which would be actually debugging and configuring the actual fascia layer. So now that we have completed the setup for the ADN glue, so the deep fascia, we can start working on the actual fascia geometry. So you can see here, I already prepared some of these components. So here we have the fascia coming into Houdini, and you can see that, yeah, it doesn't have any simulation on it. So what we can do is we can either use an object merge to bring it into a different region of this subnetwork, but I'm just going to come here and bring the fascia at the very bottom here. So let's use ADN skin, and let's call it fascia ADN skin. Great. And we can probably keep it like this. And now what we're going to do is we are going to add a target. So in this case, we are going to add several targets. We're going to add the shoulder, we're going to add the arm, and also the glue layer. So in this case, we can come to the targets pane here again, add 3 entries, and we are going to just drag and drop this in order. So here we have the shoulder. We can just drag and drop that in here. Then we can drag and drop this in here. And then as we want to retain the simulation result, we're going to just copy and paste in this geo shape from the glue output. Great, and we can come here and we can already play this back. You can see here. There we have the fascia geometry computing. And now what we can do is we can actually refine this. So in this case, what may happen is that we may have some creasing in some areas that we want to avoid. And for a better visualization, maybe I can just drop down a normal node here to recompute everything. And let's use by point. And yeah, so you can see here in some areas, we have some crevices, and in particular here in this area, we have quite some creasing, which we can actually visualize with the smooth white shaded. And now we can add an ADN relax node right here in between. So let's call it fascia ADN relax. Great. And now we can actually make this paintable. So let's come right here, and we are going to come here to make paintable. And we are going to paint the weights in only some areas. So first thing that we're going to do is we are just going to, going to flood the mesh. So let's use a fill option, come here. And now we're going to use a value of 0.5, for example, on this area right here. So we are interested in avoiding those creases. So in this case, probably this area right here is going to be more problematic. So we can come here, and then we can always cook the node, but we have to go to start frame, so it will not be interactive at the moment. But yeah, we are interested in probably this area too. And yeah, and maybe some areas up here. Great. And yeah, if we are at start frame, we can visualize the difference in result right here. So yeah, and probably we also want to use like a value of 0.5 in this region right here. And yeah, and then some areas we might want to actually use a higher value of 1. So for example, in this area right here, and yeah, in this area right here. So something like that, and probably decreasing of this area right here. And it's very important that we also pin this, and let's use 10 iterations in this case on the relax node. And yeah, that will pin the borders. You can see here that if I do not pin the borders, it will not pin it. And yeah, now we can have a look at the result. So let's have a look at the painting. Yeah, so we do not want to smoothen it out too much because we do not want to remove all of those details. So maybe what I can do now is I'm just going to use a bit of smoothing to just modulate where I want this to affect more or less. And yeah, now we can actually come here and just check this out. Yeah, and this already looks way better than before. So we avoid those creases in those areas, but we still have those details from the activation of the muscles, which is great. And yeah, now let me remove that normal node. And yeah, what we essentially want to do also, just to make sure that this is compliant with our API, we can bring this to the side. And let's just encapsulate this with the naming convention that we impose. So here we can come into the fascia to your shape name. Let me copy this over. And then we can call this ADN in. And yeah, we call this ADN out with the same name. And essentially what this tells the system is that we have this chain of deformers affecting essentially the this geometry that we have right here. So the name that we see right here. Great. So now let's play this back again, and yeah, just see the results. And you can also see the landmark being properly preserved. And yeah, overall we are preserving quite well that shape of that arm. Now, the next step that we're going to do is we are actually going to get the fat geometry. So here you can see that I have the fat. So the same thing again. Actually, let me create here a null node. And we are going to just call it with the right shape name. So ADN in fat geo shape, and duplicate this. And we can call this ADN out. Great. And now we can actually use an ADN fat node right here. Yeah, we can call it fat, ADN fat, for example. And this node requires as second input, the output of the fascia. So what we're going to do is we are just going to use also the output of the relaxation and plug that into the ADN fat node that we have right here. It's very important that the topology matches between the fascia and the fat. And now if we play this back, let me come out here, you can see that now we also have the fat simulating inside of Houdini. Of course, we can then tweak other parameters and make sure that everything is working as expected. But now, yeah, we have the arm working interactively inside of Houdini. We can jump to another frame. We'll see that it will try to adjust, which means that, yeah, we are simulating correctly. So now the next thing that we will do is we will go back and just refine a bit the muscles to be more aligned with the results that we want. So now that we have also rigged the other layers of the arm, what we're going to do is we're just going to do some adjustments on the different layers of the muscles. In this case, we want to give some more attachment and a bit of sliding to the muscles so they do not jiggle that much and do not separate from the actual target geometries. So we are just going to check out which are the muscles that we are going to use. So here, let's start off with, I think, the flexor. So this one, and what we can do here is let's just color code these ones accordingly. So we have here the flexor. Let me check here. We also have the extensor. Then we have, the brachialis. We have the palmaris longus, then the extensor, and that should be it. If I'm not mistaken. Let me just double check. Extensor, and this one, the other extensor. And then we have the extensor carpi longus. And this already goes up to the forearm. So we're going to use the ones on blue, and we are just going to refine them a bit because they are jiggling a bit too much. So we are going to start with the flexor digitorum. Let's just check here. Yeah, this one. So if you check out now the actual animation, you will see that at some point when the movement is too fast, the muscle will just separate too much from the actual target. See right there. So what we're going to do is we want to actually just paint some of the sliding and also a bit of attachment so we avoid this kind of bouncing behavior that you have right here. Great, so let me come to the actual node and let's just check the targets again. So we just have one single target. And now we can come here and we're going to paint the sliding geometry constraints. So in this case, we're going to set a value of 0.5 and then we're going to try with different values to see if we can get this more attached to the actual mummy geometry. So here we're going to paint something like this. And then very important, it will not slide yet. And that's because we have to actually use the max sliding distance. So we come to advanced dynamic properties. And here in the max sliding distance, we are going to set a value of 1. And this value will tell us that we are going to slide 1 centimeter. Just a quick reminder that the rigs for AdonisFX support have to be worked out in centimeters. So you know that usually in Houdini, the units that you would use are represented in meters. So if the mesh is not coming in into the right scale, you have to scale it up by 100 or do some adjustments there. Great. So now every time we do the change in the maps and also the values, we have to rewind. So let me just play this back quickly to see the result. We can also debug this using the debugger. So come here and use the slide and geometry constraints. So you can see there, these have been created in this area right here. And let's just check out if this is giving us the result that we want. So here, contracting. And let's see when the arm moves a bit too fast. So you can see there, it is attaching properly in this area, but in some areas we do not have the right amount of attachments. So what we can do is we can come back to the attach to geo constraints. And let's also use a value of 0.5 in this region right here. So something like this. And let's just double check that. Let's make sure that we don't paint. Well, we can also paint the exterior area if we wanted to. That will also attach some of those regions. So let's just try that out. Just be careful with the different shape that you use. Some cases you want to use the actual surface brush rather than the volume. Let me turn this off here. So that seems to be a bit more stable now. So you can see there, it is sliding. We have that attachment there, but maybe in some areas we still want to stabilize it a bit more. So we can come back in here and let's say that we want to use a value of 1 in some of the areas for the attachments. So, and actually what I'm going to do here, I'm going to just use the surface 1, and we can paint all of this area right here to attach. And we also may want to do the same thing outside and on the outside of the muscle, but and then we can also use a bit of smoothing to smoothen out all of these maps. And let's have a look again at this muscle. So it's a matter of iterating the maps, and you can also play around with different values on the So yeah, that's way better already. And it's attaching way more. We can maybe give it a bit more of attachment in some areas, for example, up here. But I think you get the overall idea of what we want to achieve here. And yeah, this is looking way better than before. And yeah, you can also tweak the stiffness of the system on the node itself. And yeah, just checking the constraints quickly. Let me go to the debugger. So here, and we also have the attached geometry, which is attaching in all of these areas. We can also change the color to make it more evident. So yeah, this muscle looks fine. And now we can go to the actual palmaris longus, which would sit on top. So what we can do is let's template this one right here. And let's do the exact same thing as before. So we can paint the slide on geometry constraints. So here, let's come to slide on geometry. And depending on what we want, in this case, probably we can use a value of 1 for the sliding directly on top of the on the actual muscle that is below, which in this case was the flexor. And yeah, we should not forget the max sliding distance set to 1, because if not, it will not display anything. We can also make sure with the actual debugger, whenever we do the slide on geometry constraints, you can see there, they are being generated. And yeah, we can debug the different lines here. So let's check that out here. And yeah, we may have to also adjust a bit the attachments. But yeah, it seems like it's adjusting quite nicely to the underlying muscle, which is essentially what we want to achieve. So yeah, it looks like in this case, setting it to a value of 1 directly really did the trick. And yeah, we can also maybe paint a bit of the attachments back. So let me come here to the attached geo. And yeah, we can either paint like a value of 1, or we can paint with the surface brush value of 0.5 here. So we actually attach properly in this area. And yeah, and here probably let's go back and set a value of 0.3. And yeah, that should do it. Maybe here we can go back and paint a bit more of 0.5. Yeah, something like that. So yeah, let's check out that muscle again. And we are going to do that for all of the forearm muscles. So yeah, that looks already a lot better now. Yeah, that's exactly what we want to achieve. Some cases we might even want to make it a bit stronger, at least here for this muscle right here. So maybe we can go back quickly to the flexor, and let's paint a bit more this value up here. So let's go in and paint, attach the geo constraints. And yeah, let's reintroduce a bit more here, value of 1 to here. And yeah, that looks already like it should do a better job of keeping that in place. Yeah, that's looking way better now. Yeah, and then we can also go in and smoothen a bit the weights, I think, because that's going to avoid those harsh cuts. And yeah, actually, Let me come in here, use the volume brush, and just give it one smoothing, and that should do it. Great, so now let's template this one. Let's template also the palmaris longus, and let's go to the actual brachioradialis. Let's see where I can find this one. Deltoid, extensor. Let me see. Extensor, deltoid. Yeah, here, brachioradialis. So this one, yeah, as before, we want to give it a bit of sliding. So here, let's just double check which are the targets. So we have here the mummy. So essentially, I think we are interested here in applying the sliding on the mummy geometry, but making sure that we do not break this area right here, which will be the one that takes care of the actual flexing. And so yeah, we can maybe start off with a value of 0.5. Just bear in mind that the solver will try to normalize the weights. Given that we are using the attribute paint node, there is no logic in place to normalize the weights while stroking. So just be careful that when you add values that you remove the values from the other multi-influenced targets. So in this case, we're going to set this to the dynamic properties, max sliding distance set to 1. And we can visualize, for example, the sliding geometry. See right there, which is great. And then what we want to do is we want to see this with the in combination with the muscles that we had already rigged. So here, the extensor, and yeah, the palmaris longus. Looks like it should work. So here, yeah, so this is looking promising. Let's see. Maybe we'll have to add a bit more attachment weights. And you have to be careful because we essentially do not want to remove completely the ability to add the jiggly effect. And you can see there, yeah, in some areas, we are still going through the arm mummy. In this case, it should make sense because we probably want to add a bit more attachment in this area. So actually, we remove the highlighting here. And let's go to the attached geo. So here we had the baseline, and then we had the attached geo in this area for the other muscle. Let's just double check the targets. So here we have the flexor, which is the one that lies just below. And yeah, what we can maybe do is we can actually increase a bit this area right here. And attached geo constraints, yeah, we can maybe even increase a bit the value here. Let's put the surface brush again and all of this area right here, but making sure that this area is still free to move. And yeah, we can then also use a bit of smoothing, but let's just see how this is working in combination. And let's just double check because we can actually here with the object merge, just quickly see how all of these muscles work together. So yeah, the forearm is looking better now. Just double check with the fast movement. So we still have those activations happening. And yeah, here, let's see. Yeah, we still have to work on some of these muscles. But the ones that we have modified, yeah, I think we can work with that already. Okay, so that one has been modified. These ones have also been modified. So let's have a look at the extensor carpi longus. This one exactly, this one is the one that we have not modified yet. So as you can see here in this area, it was actually going in quite a bit into the geometry. So really depending on how you already painted the different weights, we can probably increase a bit the overall painting of the attached geo. Let me go to volume. So in this area here, let's just attach this a bit more to the actual mummy. And again, we can go and paint the sliding geometry. So in this case, probably this area is the one that we really want to target. Right here. And we can use a value of 1 here in the dynamic properties, the max sliding distance. And yeah, let's see how this behaves. So let's come in here. Okay, and it doesn't look like it's penetrating all too much. In some areas, we might have a bit of penetration, but we can really find the compromise of which is the value that we want to use. And you can see right here, in this case, it's pretty stable. And we can then loosen the muscle if we want to with different values of stiffness. But yeah, this already looks pretty good. Now, we can also probably do some adjustments because they're in the extensor carpi longus. Yeah, it looks like it. We can maybe play around with some of the targets and add more targets, but let's go to the next muscle. Let's go to the extensor digitorum. This is the flexor. So this one right here. Great. So here we also going to do the sliding constraints. So let's go back to this muscle. Let's check how many targets. So here we have just the mummy geometry. Of course, we can then add more places where we want to actually attach the muscle to muscle attachments. But yeah, let's go here and see the attached geo. And yeah, we also have the sliding geo. Let's see how this muscle behaves. So maybe some cases we don't want this to slide all too much because it might kill just the inertias of the forearm muscle. Let's see the fast movement here. Okay. Yeah, it's looking quite stable, but you can see that, yeah, there's might be a bit of offset. So maybe here we can come in and start painting some slide on geometry. So here again, 0.5, and depending on what we do, we can actually use a value of 1. So something like this, for example, and make sure that we also do it in this area. It just allows the muscle to be more aligned with, with the underlying geometry. We can debug this, of course. We can come here and check out again the slide on geometry option. And yeah, of course, here you won't see anything because we have not set the max sliding distance to 1. And we can come here and change the color to make it a bit more obvious. See there? And if you can't see the actual connections, we can always come into the wireframe ghost mode, and there we can really see the different attachments that have been created. Great, let me go back to smooth shaded, turn off the debugger, and yeah, just play this again. See that bulging happening. So yeah, it's quite stable. And yeah, maybe in some areas we need to review a bit of the attachments, like here. So something that I'm going to do now. So we do not want to affect, let's say, the areas that are going to be flexing, especially on the wrist. So let's go to attach the geo constraints. And yeah, maybe here can use a value 0.5 just inside. Really depends on which painting you've done, how it will affect the dynamics. But here, I think it's very important that we keep this loose. And let's see again now. So this movement is not the fast movement yet. So let's see what happens when the arm moves quite fast. And yeah, we still have a bit of penetration here. So we can maybe go ahead and just pin this area right here. So let me actually set this. Can actually be probably to like a value of nearly 1 here, but I'm just going to be a bit conservative here. And just going to use here this value, maybe even a bit up. And yeah, let's see this again. Rewind to, so the weights are being picked up. Let's see the fast movement in a second. Okay. Yes, still a bit of adjustments here, but overall I think we may be able to live with this for now. You can always go back and check out different maps, but yeah, let's move ahead with the next muscle. The carpi ulnaris is, I think, the last one that I need to do. I think, yeah, this one. So yeah, this muscle, we can check out different targets. So here we just have the mummy. And yeah, in this case, we can go a bit faster and use the slide on geometry. And yeah, we're going to use a value 0.5 in this case. Again, the areas that we really want the muscle to slide onto on the bone, and yeah, make sure that paint also this area. And then for the attachment to geo, I can go ahead and probably paint a bit more this area right here. Great, something like that. Let's see how this behaves. So we also do not want to kill the dynamics, so we have to be a bit careful there. But overall, I think that looks a bit better. Yeah, we still have some adjustments to do in this area, I think. Can maybe attach this a bit further. So here, it's the groom. So yeah, let's use a value of 0.5 here. And let's use a value of 1, just a bit further up, like this. And I think that should work out now. Let's see. And maybe it's a bit better to just evaluate this as a whole. So let's have a look at all of the forearm muscles. Let me remove this right here. Let's see there. Yeah, so all of these activations are still present. And yeah, here we can see that, yeah, we still have a bit of work to do in some of the muscles. So yeah, we can select, for example, here, one of these faces, and let's only show selected. So this is the extensor carpi brevis. Extensor carpi brevis, and yeah, looks like that's the only one. Nice. So let's have a look. Extensor carpi brevis. Yes, this one. Nice. Okay, so for this muscle, we are going to try to be a bit more aggressive on how we're going to attach this. So here, let's just have a look at the different attachments. So attach a geo. And let me see, did I paint sliding? I think this is the muscle that I've not modified. So that would explain why that muscle is going in that direction. So let's use a bit of slide on geometry here too. In this area, let's not overdo it. And attach the geo, I'm going to also increase a bit here, this area. And yeah, we can then go always in and modify a bit the painting. So here, let's see if I did change this. No, I have not. So here, the max sliding distance set to 1. And yeah, let me just quickly play this back. See there. See, so it is sliding, but yeah, we may want to attach this a bit further. So let's have a look at the attacher geo, and yeah, I'm going to just increase a bit. Let me use the volume paint brush. Let me increase this a bit in this area just to attach it further. And yeah, that should do a better job at keeping everything in place. So here, let's have a look. That doesn't break anything in the mesh itself. See there, yeah. So yeah, maybe can be a bit more conservative here, and let me go back into the actual painting. And I think here what we can do is we can just smoothen this out a bit just to make sure that it doesn't break the mesh. Great, so now let me go back and check on all of these muscles. Let's see if that improved the final result. Of course, if you scrub the timeline, you can also see it better in this case. And let me go out of that selection mode. Deselect this right here, and let's come into the camera view. And yeah, this is looking quite good. So let's see when the fast movement happens, if we can actually get the muscle to follow properly the arm. And it looks like, yeah, we still have a bit of collapsing in some of the muscles. So for example, I think that it was the one that we have just modified. So here, so carpi brevis. Yeah, this one is still a bit too, yeah. We have to change the painting a bit here. So come in again in here. And maybe what we can do is that we can just exaggerate a bit more the sliding here in this area. And let's just see this again. So here, let me go to a different frame. As you can see, I can go to a different frame, it will try to converge to that pose. And let's see now. Okay. Let me see when the muscle goes down. Yeah, it looks way better now. Here we still have a bit of that collapsing happening, which I think could get resolved with a bit more of attachment in this area. So let me just double check that out now. So yeah, I think here we have to use a bit more of attachments, because if not, it will just try to collapse. And here we can also use a bit of smoothing. And let's try again. So let's go to a different frame. And let's play. So yeah, we still see a bit of collapsing happening here. So it might just be that we have to modulate this in a better way with some better painting. So let me try for the last time. Let me just double check that I added, the max sliding distance is correct. And let me check how many targets I have for this. I just have the mummy, which makes sense. And yeah, let me check the attached to geo constraints. So maybe we have to go up a bit more in this area right here. Set a value of 1. Just right here. And yeah, do something like that. Let's see. Let's see if this would resolve what I'm seeing. Yeah, this is way better now. Great. So yeah, we have now tweaked the attachments of the forearm. Let me just play this back once. So we can see all of those attachments. Yes, great. That looks very good under that stress condition. And yeah, we can see that here also the forearm is behaving quite stable. Can then of course go in and refine a bit more the painting. But overall, compared to the upper arm, I think we are in a good shape to also modulate the muscles on the upper arm of this asset. So before jumping onto the forearm, I just wanted to do a quick adjustment to one of these muscles. And in particular, we were going to check out the extensor carpi longus. So let's have a look at this one. And yeah, I think here the issue that happened is that I missed some attachment that I would have liked to add. And yeah, essentially we're going to attach this to 2 other muscles, the ones that are on the side to reduce the gap. So let's just add this here. And yeah, let's just check out, this would be the brachialis. So here, let's just check that one out. So here, this one. So we actually want this one to come in here. And then we have the extensor carpi brevis, which will be, let me check, this one. Yeah. So come in here and drag and drop this in here. Great. It's because I missed these ones and I really want to attach these ones to the to this muscle. So what we can do is now, after having added all of these, we can make this paintable again. And essentially we'll update the weights that we have in here. Well, not the weights, but the actual paintable maps that we can apply. So this was the baseline, which would be the mummy. But now we also want to attach it to the different muscles. So here we said that the first one would be the brachioradialis. So let's check that one out. And yeah, here we can attach this in this area. So let's just make sure that we follow this muscle. Let's use a value of 0.3 in this case for all of this area, because we want this muscle to follow this one right here. And yeah, we can maybe smoothen this out a bit. And then we have the other muscle, so we can come back to the original and check out the extensor carpi brevis. And yeah, let me check where I have that muscle right here. Great. So we can come back into the painting here and attach the geoconstraint 0. And let's use also value 0.3 in this area right here. So it will really attach also to the muscle that has it, well, that's lying on the side, and everything is more attached together. Great. So now let's have a look again at all of the muscles, just to make sure that I've not missed anything. So yeah, in some cases it may not be necessary to do that much attachment. So in this case, maybe it's a bit too much, but it really allows all of these muscles to be more attached together. So yeah, in this area, I'm not liking this behavior right here. So let's come back into the carpi longus. Yeah, this one, and let's check out the weights again. So here, and yeah, here the painting. So in this case here, we had attach the geoconstraint 0. So maybe we want to free this up a bit more in this area here and smoothen it out. And the same with the other one. We don't want to overdo it. So in some cases, we might want to reduce it even further. So something like that. And let's check out just this muscle quickly. So yeah, in this case, we may want to do some further adjustments in this area. Let's just compare quickly without those attachments, how it will look like. So yeah, not much of a difference. Let me come back and paint this a bit better. So maybe we have to actually increase the value. So here we have the attachment to geometry number 0. Looks correct to me. Then we had this muscle, so maybe we have to increase this slightly up here. So let's actually use a value 0.1 up here to just target that muscle that we have on the top. And we can always increase it later. And then we have this one, which we may want to just use a bit more in this area. Let's see how, and as always, we have this warning because the weights are not normalized. We should probably reduce it slightly in some areas. And yeah, that looks already better than what we had before. And let's just check it out all together. Oops, sorry for that. Let's have a look at all of these muscles together. Yeah, that looks a lot better now compared to what we had before. Great, so yeah, I just added 2 more targets. So that will also show you how you can add targets after already having painted some other targets, just come to the make paintable option, and now, yeah, finally we're going to check out the other muscles on the arm. Let's take a look now on how we can attach the muscles on the upper arm area. As you can see right here, we have now worked on the forearm muscles, but we still have to do some adjustments on these muscles right here, because when you have like a very fast motion, it just feels like all of these muscles jiggle a bit too much. So you can see right there, they flop quite a bit. Great, so let's just quickly color code the ones that we are going to modify now. We are not going to modify the deltoid, but let's take a look also at adding this here, this one, and this one. Okay, let's give it a different color, something like that, so we know exactly the ones that we have to tweak. Great. So let's start with the brachialis muscle. This is something that we have here. Great. And as you can see here, yeah, this muscle may be moving a bit too much to the side. So what we're going to do now is we're going to paint the slide on geometry constraints. So let's come here. Slide on geometry. And we are just going to paint this to a value of 1. Yeah, we already have that here in this area right here. So let's do that. Something like that. And we can't forget the actual max sliding distance. So go to dynamic properties and let's set it to a value of 1. Great. We can debug this too. So here, let's go to slide on geometry. And you can see there those attachments appearing. Great. So now let's have a look at the results of this. Okay, that will still give us some interesting dynamics, but let's also paint, for example, some of the tendinous areas. Here, let's use a value of 0.3, for example. Let's paint it down here too. Something like that. And yeah, we can maybe flood this a bit. Great, let's have a look again. Okay, that works a bit better. Yeah, we can then also maybe add a bit of attachment to geometry here. Let me quickly come in here and use a value 0.5 in this area right here, especially. Something like that. So the muscle is more attached to the actual bone itself. Remember to rewind after having modified the values. And yeah, that looks a bit better. Great. So now the next muscle that we're going to work on, and maybe we can template the brachialis muscle, is the bicep. So for the bicep, what we're going to do is we're going to just paint the slide on geometry. But this time, let's check which is the attachment. So this would be 0, 1, 2, and 3. So 0, 1, 2, we want to modify the one for the brachialis. So let's come here to number 2, slide on geometry constraints. And we're going to paint the area that is around the brachialis. So let's use a value of 0.5 in this area right here. Something like that. And yeah, we may also be able to add a bit to the mummy arm. So let's have a look at, that's the index number 1. So let's go to sliding geometry here. And yeah, we can paint this area right here to slide on top of that area right there. And of course we can smoothen this out. And yeah, let's do the same thing for this area right here. Great. And yeah, now let's not forget, this will not actually create sliding. So we have to go to the max sliding distance. And as for the other muscles, we are going to set this to a value of 1. And now let's have a look at the behavior of the bicep muscle. So it's still bulging like we wanted it to. And now the important part is that it will get properly attached to the brachialis. And yeah, it looks like it's a lot more stable than before. And yeah, in case we have some collapsing here, what we can do is we can come to the, let's see, the fibers multiplier, and we are going to just paint this in this area to 1. So it preserves also the volume accordingly. So there's no collapsing happening in this area too. Maybe even a bit further, something like that. And yeah, let's just have a look at how that looks when all of the muscles are simulating. So here, so we still have that bulging of the bicep. Okay, still see the dynamics happening. Yeah, and that works a lot better now compared to how we had it before. We can, of course, add more attachments to make it even more compact, but we may kill the overall dynamics of the system. So we have to be a bit careful there. So yeah, actually this one we are not going to modify either. And now we are going to just focus on the tricep. And actually what I'm going to do before I do that probably is let's go back to the bicep. And let's just increase a bit the attached geometry to the brachialis too. And let's come here. And in this case, we have to check targets, so 0, 1, 2, and we're going to go to the attached geometry. Number 2, great. So that one is for the brachialis, so we are going to, yeah, just increase this slightly. In this case, maybe what we can do is 0.3, maybe we can use as a value of 0.5 there, or even 1. Yeah, just paint all of this area right here, maybe even smooth it a bit. And yeah, that should work better now. More compact with the actual brachialis muscle, with that sliding appearing. Yeah, that looks better. Great. And finally, we are going to tweak, like I already mentioned, the tricep muscle. So we are going to check the targets. So you have the shoulder and the arm. So we have to actually focus on the second one. So let's go to slide on geometry. And we're going to just paint this, let's see, to a value of 0.5. So we want this area right here. Except for the actual tendons, you don't want them to slide. Great. And we can't forget that we have to set the actual max sliding distance here. So this set to 1, go to the debugger and see the sliding geometry constraints being created there, which makes sense. And now we can have a look at all of the muscles in combination. Let's just see if there's any other muscle that we have to tweak. Let me remove the restriction here. Okay. We have that activation of the tricep. And yeah, overall it looks quite solid. We can then go again when checking out the other layers and to tweaking other aspects of the muscles. But let's just quickly have a look at how the fat looks like. Okay, looks like this is bulging quite nicely. We can still see those dynamics happening, which is exactly what we want. Yeah, you can also see the deltoid still jiggling. So yeah, that looks like a good first pass of the overall arm setup. And now we're going to set up the other layers, which would be the skin and also the skin merge. So now what we can do is we can start working on the actual sim skin. So let's have a look at this static cache that we have for the simulated skin. Let's create a null node. And let's copy and paste in the value that we have here. And we're going to call this ADN in. And the name of the geometry, we can copy and paste this and use the out naming convention. So this will dictate that everything that will be in this region will be used for the deformation of this geometry shape that you have right here. So let's create an ADN skin deformer. And now we can just copy and paste in the name here. And yeah, let's remove this right here. Then we have to add the target. So in this case, the target is going to be the fat geometry. So we add an entry here and just drag and drop it right here. And then what we can do is we can start painting the maps. So let's come in here, make this paintable. So it will actually create like an initial setup. Essentially what this utility does, it just sets the default point attribute values to the paintable maps that you can find in this section right here, which are disabled for API compatibility reasons. And then we also have all of these entries that we can paint. So yeah, what we are interested in is essentially painting the sliding. So we can come here to the slide constraints. And yeah, we can be conservative with like a value of 0.6, and then we can increase it further to like a value of 0.8. So maybe let's use a value between 0.7. And we are going to start painting this area right here. So wherever we want the sliding to appear, maybe even here a bit. So yeah, maybe something like that, just to show you how we can simulate the sliding. Just make sure that this area is then painted properly with the hard constraints. So what we're going to do now is we can either do this within a wrangle where we normalize the weights, but what I'm going to do is I'm just going to paint this manually to try to match the region there where we have painted the sliding. So here, let me move this a bit here. So something like that. Let's check out the sliding. So here, if we maybe normalize this a bit, and then very important that we keep this insertion here properly painted to 1. Let's do that. And also this area right here, that's properly painted. So yeah, something like that. We can then always increase the radius of influence. And yeah, let's go to advanced settings and use the dynamic properties and set the max sliding distance, for example, 1 centimeter. And we can play this back and see the results. So you can see there already the sliding happening in this area right here. Let's wait for the muscle to do a, yeah, you can see there the sliding happening in this area, the forearm, which is essentially what we wanted. Yeah, and we can go in and tweak the maps even further to reduce the dynamics. But yeah, maybe in some areas, what you will notice is that you might have collapsing. For example, here, we also have like this area where we may want to relax a bit the geometry. So what I'm going to do is I'm just going to drop down and relax. Let's make sure that we are at rest pose. Let's use skin sim, and now I'm going to pin the borders and make this paintable. And now I'm going to start painting. Let's set the weights. So we are just interested in just that region right there. Can maybe add like a tiny bit of relaxation overall to the mesh on the skin. And then here we can use a value of 1 to avoid that kind of creasing that we had there. Okay, let's see, let's check this out. You can see there the effect of the relaxation. Maybe we can even make it a bit more evident in this area. So let's use a value of 1 just right here. Let's rewind to see the weights being applied. Yeah, that looks way better now. And then of course we can, if we have problems still with other layers, we can go back and modulate the relaxation, for example, the fascia, which is something that I'm going to quickly do. So here, let's go. You can see there the sliding happening and all in this area. So let's see if there has been some collapsing. You can see there, yeah, may have to paint a bit better this area or add like a bit more of hard constraints, but that's something that we can always modulate from the map painting. So yeah, we can, let me quickly go into the painting again of alien skin, check out the hard constraints. And yeah, in this case, we may want to multiply a bit the value. So let's say that we had a value of, yeah, we have painted the inverse, so 0.3. So we may want to increase it a tiny bit. Let's use a value of 0.2 or 1.2, sorry. And just increase this slightly in this area. Great. Let's check this out now. So we do not really want this to slide all too much, but we do want to see the sliding happening on the mesh. So yeah, you can see there we may have some collapsing happening, but that's probably because of the fascia. Yeah, so that's way more controlled. We can still see the sliding happening in this area. It really depends on the use case that you want to give. So here in this area, what we're going to do is we are just going to modulate a bit more the relaxation of the fascia. So here, the weights of the relaxation on the fascia. Just check out, yeah. So this was the smooth multiplier actually. I just realized that probably what we should have tweaked is the actual weights rather than the smooth multiplier. So actually that's exactly what I'm going to do now. Just going to set this back to 1, and yeah, let's set this maybe to a baseline of 0.1, and then I'm going to start painting the areas that I think are more problematic. So essentially it would be this creased area right here, then probably this area right here that's going to collapse, and yeah, probably this area here too, and this area here. So yeah, the smoothing multiplier will just tell the system how much smoothing to apply in certain areas, but we also want to modulate the relaxation. So it's important that we try to find the balance between the two weights. So yeah, maybe something like that would work. And then we're going to use some smoothing here. Let's just have a look at that. The fascia. So no collapsing. And we still retain the activations. Yeah, that looks quite good actually. So let's see how that behaves again on the skin. See all of those contractions of the muscle. And yeah, you may see that at times it just looks a bit weird. Let me add this node right here because we do not have proper lighting in the scene. So yeah, there you see the sliding happening and all of that jiggly behavior. Then of course we can go ahead and fix some of the areas where we want to preserve the landmark, and also make the muscle not intersect that much with the actual arm geometry. But I think that yeah, it's good enough for a first pass. So let's continue with rigging this arm. So maybe in some cases we actually want to stiffen up the muscles giving a different parameter. So for example, we want to modulate and activate the muscles under velocity, which in some cases happens. So what we're going to do now is we are going to create a sensor, a position sensor. So that's a new one that we have not created yet. So alien sensor position and alien locator position. Great. So yeah, we are just going to call this arm. Great. Now we're going to select one of these joints as the driver. So we are going to select this one. So as before, let me click on this, and we're going to select not this one, but if I'm not mistaken, this one. No, metacarpi. Let me see if this is the right one. No, this is the ulnar. Wrist. Yeah, it should be the wrist one. Great. So let's bring in the wrist one. Let's bring it inside of here. And let's have a look at the copy and pasting this also to the actual sensor. Great. Let's cook this. and we may want to make this bigger. So let's use a value of 5, and we want to display the velocities. Great, so now when this starts moving, you will see that it will start outputting a different detail attribute. So you can see here, we have the acceleration and velocity. So whenever this modifies, you can see that it changes the activation output. So now we can come here into the output, and let's just see which is the velocity, the maximum velocity, when the arm is doing this very fast movement. So not this one, but more this one right here. So yeah, you can see it's around 300, almost 400. So that's the value that we're going to take, and we are going to set this, in this case, let's use it here with a value of 300, let's say. Okay, so now you can see there the velocities. And yeah, there we are activating the muscles. And then when this very fast movement happens, that's where the muscle should activate even further. Great, so now the usual drill of this is that we're going to apply this to all of the muscles. So we can come here, and we are going to use a detail expression in this case. Actually, let me do this like this. So we're going to do detail, then the name, and then we are going to do ADN activation velocity rather than distance as we had before. Let's just double check that that is actually being picked up properly. You can see there, yeah, it will start to activate slightly. So yeah, then we can just copy and paste this over to all of these muscles. So you can see here, let's just repeat this for all of them. So copy and paste this over. So yeah, here we can see that we probably missed the extensor carpi brevis. So let me review that in a second. And yeah, here, this one, and let's do that for all of them. Right, almost there. We can, of course, yeah, select multiple nodes at once, but given that they have different activation lists, so it's a bit more difficult to modulate. And yeah, we can also do that probably via script. So yeah, there are many ways of improving this workflow. Actually, let me go back to the one that we had before. Yeah, it was this one, a carpi brevis. So this in theory should also activate with this one right here. So let's just see which one that is. So here we have the flex, extend, arm pronate. So this finger. So wrist flex, it's the other one. So extend. Yeah, it should be extend, the one that we are going to use. So yeah, let's just copy and paste this over. Okay. And now, yeah, the muscles will actually contract under that velocity change. So let's have a look at all of those muscles together. Actually, let me hide other objects. So yeah, now under that velocity change, we will actually see the muscles contracting more. See there. And yeah, we'll just make sure that the muscles are more tighter, sorry. And yeah, that's how we can modulate essentially the actual velocity. And ingest it inside of the different muscles that we have. So now let's jump onto the final layer, which would be just merging the results together with the animation. So the last thing that we have pending is to actually merge in the animation with the simulation, and we can do that with the actual ADN skin merge node. So here we're going to get the rendered skin, which you can see has no simulation or animation. Then on the other hand, we have the actual anim skin, which we do not have the animation of the rotation. So let's copy over this name and do ADN skin merge right here. Let's create two null nodes. And out. And this is just for convention to then support the API. So here, the skin merge, we need to add some targets. So sorry, here we can add multiple for the anim skin or the sim skin. So here, let's drag and drop in the sim skin. And then finally, we also have the anim skin. Great, so we have that there. And if we play this back, you will see that this is just the simulation results. And yeah, we may want to blend in some of the results up here for the anim skin. So let's again make this paintable and come to the actual blend weights. See here the blend, and we're going to set this to value 0 in this area right here, for example. We can then of course retain everything just from the simulation, but we may just want to pin this area to fully match the animation. Great. And yeah, we can maybe smoothen this out. And now let's have a look at this. Let's see now up here, this will probably be a bit more static than before. See, yeah, this area is following the animation. So yeah, we may want this effect or we may not. But yeah, this looks quite good. And yeah, that would essentially be everything for rigging the arm. Let me just show also again here. Let me remove the joints and also the rivets. And let's just quickly have a look at the final result of the rendered skin. So let's just play this back. See that landmark there. You can see that sliding, those dynamics appearing. And yeah, we may want to just go back quickly and check out what was going on with the tricep muscle. So let's have a look if it's actually the tricep or it's actually something else. But you can see that the landmark is quite, yeah, it's quite visible. So let's just see what happens when the movement is fast. See there, we play one frame at a time. Yeah, you can see there. Yeah, in this case, yeah, we may want to attach here the tricep a bit more. So let's do that quickly. So let's go into the tricep here. And we notice that this area is the problematic area. So come in here. So attach to geometry. So this one was for this area right here. Great. But we want the attached geo one. So here, let's use a value of, well, we can try 1, but let's use a value of 0.8 in this area right here. Just to make sure that this is properly simulating. Yeah, that looks way better now. So let's have another look at the rendered skin, and yeah, we can bring this down here so we know that the layers are going in this direction. Maybe you can add this right here. Something like this. Yeah, we can make this a lot cleaner. But yeah, now let's see that landmark. Let me rewind again just to make sure that so yeah, you can see that landmark properly showing. Yeah, we can maybe attach this directly to the bone. That's something that we have not done. So we actually do not see that mummy geometry peeking out here. But yeah, let's just check out what happens when the movement is quite fast. You can see the landmark is still there. Let me see this movement right here. This was the problematic one. And yeah, that is way better now. So yeah, that would be it for rigging the arm inside of Houdini using AdonisFX. So I'm going to be presenting you the final scene for the arm where we did some tweaks. This is essentially the one that we want to share. And here we have the rendered skin simulating with all the layers underneath. And in this scene, what we'll find is essentially the locator and sensor setup right here, where we have the flexion, the extension, pronation, supination, abduction, adduction, and also the velocity sensor. Then we also have all of the muscles configured. So we are merging this all together to be able to create the deep fascia later on, but we invite you to actually go to each muscle, for example, here the deltoid, and check out the paintable maps. So here we have the attached geo constraints and the fibers that we have combed. Then we can go into the glue layer. So right here, and we have, yeah, the glue constraints that we can visualize here with the debugging system. And we can also check out the different paintings that we've done. For example, here, the glue resistance to avoid the collapsing of some of the muscles on this area right here. And yeah, you can see that here, we're simulating this to kind of keep the muscles together and mimic the deep fascia. Then going on to the next layer, we have to the right-hand side, and as usual, we can also check out the different connections with view, show all nodes. So we can see that this is going into the fascia. Let me turn this off. And here the fascia, just making sure that, yeah, we are not painting anything because the default value here of the hard constraints will be set to 1. So you can debug this with these messages right here, and also check out the different point attributes. But yeah, we did some tweaking on the actual relaxation. So here you can see that if we go to the attribute paint node, here we have the weights to actually avoid the collapsing of some of these areas. And yeah, this is very important also to preserve and not have any relaxation in this area, because that's where we want to actually preserve the landmark. And yeah, then we can go to the next layer, which would be fat. And in fat, we did some adjustments. Here, let me just play back some frames. And let me go to this node right here. So for example, the hard constraints to keep this landmark in this area, very important. Then we also removed the shape preservation in this area to keep that bony area pointing outwards. And then finally, we also added some relaxation to the fat layer. So here, just making sure that we keep this properly applied. And I guess, let me just quickly do that here. And we also want to, not relax this area right here, because essentially that's where we want to preserve that landmark. Let me do this like this. And yeah, this will be the relaxation of this layer. So yeah, it's just because of some of the collapsing that may happen from the muscles. So we add some relaxation to the fat layer. Then the next layer would be the alien skin node, or the final skin. And what we've done here is we have removed slightly the shape preservation, so set it to value of 0.5 in this area. And you can go ahead and also check out the different values for the maps that we have painted. For example, here, slide constraints. And again, we have the relaxation. So here we wanted to relax a bit this area right here. And yeah, everything else is just set to 0, so the landmark should be preserved. And we would get something like this. So actually, let me just double check one thing, because I think I missed one of the maps that I wanted to show you. Here, the compression resistance, we have removed it a bit in this area, and also this is just to avoid the wrinklings from appearing, the wrinkling. And then we have also the stretching resistance, which we set to 0, so we actually preserve that landmark, which is something that we want. And yeah, and then this would be the sim skin. And then finally, we have the rendered skin, which is bringing everything together with animation. We have exaggerated this area just a bit to follow the anim mesh. But yeah, here you can see the landmark properly preserved. And yeah, you can see all of these dynamic sliding happening for this muscle and the skin. So yeah, that should be it for this tutorial series. We will do more tutorials on more specific features, for example, like self-collisions or painting other deformers. But for the time being, this is all for this tutorial series. Thank you.